we're talking about the limit of rational functions. The very first case was the case that a is in the domain of the function, so you're going to use direct substitution. Now let us move on to case 2. In case 2, a is not in the domain of the function. So give us an example. In this example, I have x squared minus 1 divided by x minus 1 as x approach 1. This is a rational function. The domain of this function, guys, we don't simplify this. First, we need to find the domain, then we check to see what technique we can apply here. The domain is all real values, like x, such that the denominator is not 0. Or it can be written as all x values, such that x is not 1. So any real number is acceptable except for 1. We can rewrite this as negative infinity to 1 union with 1 to positive infinity. Or basically, we have R, or all real values, minus the set including 1. Okay, we know that 1 is not in the domain of the function, but we are approaching, getting closer and closer to 1 from left and right. What are you going to do? You're going to try to simplify. Try to simplify. But how? This guy is equal to the limit of x squared minus 1. X squared minus 1 can be written as x minus 1 times x plus 1. On the denominator, you have x minus 1, and x approaches 1. You might say, hey, how did you simplify this? From algebra. From algebra, we know that if we have a squared minus b squared, this can be written as a minus b times a plus b. So basically, you have x squared minus 1, which had originally 1 to the second power. It's invisible too. So it is x squared minus 1 squared, which is x minus 1 times x plus 1. That's how I ended up taking x squared minus 1 and write it in expanded form like this. Now we can get rid of common factors. X minus 1 and x minus 1 are common factors. Cancel out common factor, which is x minus 1. So this rational function simplified to a linear function, and x approach 1. Since you have a linear function, to find the limit, we can use direct substitution. Use direct substitution. So it is 1 plus 1 or 2. The limit of this rational function is equal to 2. These are the steps that we took. And this is your second case.